if it is true that sine beta plus alpha is BD plus E to the F over AB, for which I hope I have proven to you that that is the case, and now there's a couple of things that we can consider. This length BD, we have fresh just stated that cos alpha sine beta is BD. So I'm going to, instead of putting BD, which I've done here, I'm going to put cos alpha sine beta. Just done. Next thing we have done, or in the past we have described, is that E to the EF is sine alpha cos beta. So instead of E to the F, I'm going to put sine alpha cos beta, and E to the F can go about its business, get out of my house. Now, finally, I'm going to realize that AB has always been 1, and so there's no reason for AB. AB can now just be 1, and division by 1, it does not make a change to the numerator. Hence, sine beta plus alpha could be described as cos alpha sine beta plus sine alpha cos beta. Something along those lines. Another way of writing that, though, is to put the causes in the middle, like so, and the sines on the outside, like sidemen. You've got sine alpha cos beta plus cos alpha sine beta. Now the alphas and betas are in alphabetical order. And also one way to aid in recalling them perhaps could be said to recognize that the causes sit in the middle and the sines sit on the outside, in addition to the alphas and betas being in alphabetical order. Often written in your textbooks, such as this. The sine A plus B is sine A cos B plus cos A sine B. And now perhaps we have a story or a narrative as to where this equation comes from, what it represents, how it is a depiction of a right angle triangle based on two right angle triangles sat on top of each other, wherein the hypotenuse of the bottom is equal to the adjacent of the top, and that the hypotenuse of the top is of a value 1, and that the alpha plus beta angle is this large angle when you add these two together. That is what this represents, and that is all you need to know, other than to be able to do a little bit of algebraic manipulation with it for the majority of problems in geometry, in my opinion. And now let's apply it so that you can see the degree to which that might be true. Now let's, of course, when we're doing problems, let's take a look at what we've been given. We've been given simplify 2 sine 15 degrees cos 15 degrees. What does that mean? What do we know? We know the angle is 15 degrees, particularly one angle. We'll have a conversation about that. But we know the angle is 15 degrees. We know sine and cos are multiplied together. There's a sine times cos. We know they both share the same angle. Their sine's angle is the equivalent of the cos's angle. And there is a 2 as a coefficient. This 2 is looking at me like, yo, hi. And I'm like, all right, I need to well consider you. Next stage then. What do we know? We know this double angle formula. And in a lot of exams, for example, if you're doing A-levels and IB, it's given. If it is not given, it's not too difficult to memorize, particularly for the sine. It is cos on the outside, cos on the inside, sine on the outside, and these are in alphabetical order. Now, one thing to be aware of, I'm now going to look at what we know and see if I can create a connection between these things. We have two angles here, but I'm aware that the angles in here are exactly the same. So there's not a difference between the angle for sine and the angle for cos. So considering that, what I'm going to do is I'm going to say let's have a go at saying that imagine that alpha and beta were the exact same size. They're not in this diagram, but imagine that this angle and this angle were the same size. And bear with me as to why I'm going to do that. First of all, A in this formula, which was alpha in my formula, in the one we've been discussing, or in these circumstances, A, I'm going to call X. And B, I'm going to call X as well. Why? Because all I'm suggesting in a mathematical way is I'm saying they are the same. That's all I'm saying. And so if you see alpha plus beta, it would just be X plus X. Or A plus B would just be X plus X. They're both X. They're both the same. X plus X is just 2X. And so we're going to utilize this to see if we can simplify this down into something that's more useful. First of all, first thing you can see is that by doing that, by applying this concept, sine beta plus alpha becomes sine X plus X. That is what's happened here. Rather than having beta plus alpha, I'm saying these are the same. They're both a value of X, any value of X, perhaps limited to being acute angles in these circumstances, but that's actually not the case overall. A lot can be done with those angles to change the structure of this, but for now, in this problem, for our discussion, we're going to assume that they're going to be around 30, 40, 50 degrees, And the majority of problems will stick to that notion at the IB or A level. And if they don't, I apologize for that comment, as it makes no sense otherwise to that. But for now, assume that these are two small angles and they're exactly the same. Beta plus alpha, x plus x. X plus x is 2x, so that's what I've done in here. There is no requirement for sine alpha cos beta, cos alpha sine alpha. Cos alpha sine beta. There's no requirement for that. They're all just x's. They're just x, 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 x. Notice that cos x sine x is the same as sine x cos x. There's no difference between these two. That statement and that statement are the same. It's like 1 times 2 is the same as 2 times 1, or synonymous to that. Hence, I can then say that this plus this is 2 of them, leaving me with sine 2x equals 2 sine x cos x. Now and this is something that you'll definitely get used to as you do more and more problems and build up your repetition to the degree that you're quite comfortable with these. That does look remarkably similar to this. They are very synonymous. Now, here's the thing. 2 sine x cos x, the angles are the same. As I've said, the angles seem to be the same. Both of those share the same angles. Now they're 15 degrees. In what we have so far, they're x. So let's implement that. Let's put a 2 sine 15 cos 15. And now it is exactly the same as this. So to what degree can we solve the problem of simplifying it? How do we simplify? Well, 2 sine 15 cos 15 must be equal to 2 sine x. Sine 2x. Sorry. Sine 2x. Sine 2x. Sine 2 15. So another way of looking at it is if x is 15 in here, like so, then x must be 15 in here. Hence I have sine 2 times 15, which is sine 30. Sine 30 is therefore 2 sine 15 cos 15. If I type into my calculator either of these, but particularly the concept of sine 30, which is very much a simplified version, I have the most simplified version without it becoming just a numerical value and keeping the function sine in there. And finally, sine 30 is always a situation where the hypotenuse is twice as large as the opposite, and so the most simplified version you can get is half. And that therefore is the solution to there. Now, to that problem. Now, you will get other problems, but what I wanted to do is to make this slightly more universal, because the description I gave was only for sine alpha plus beta, and the problem I gave was quite specific, although I wanted it to be so you can see the degree to which you can apply this. Now, that's what we're going to do for this last conversation. The last conversation we're going to have is to recognize the triangles that we did this with. This is how we produced this formula. That formula comes from us taking our time, utilizing just sine and cos, and trying to change these letters that represent the sides, BE, DE, DC, and so on and so forth, and converting them into cos, sine, sine alpha, cos beta, so on and so forth. You could do the same for cos. There's nothing stopping you from doing the same for cos. You would just have to recognize what triangle this represents. For cos, for double angle, we're always looking at this right angle triangle, step 1. For double angle, we're always suggesting that that is one angle alpha plus beta, alpha plus beta, alpha plus beta. For sine, we specifically went for figuring out opposite divided by hypotenuse. We started off with BC over AB. For cos, you would do AC over AB. And with the same technique, you will come up with, and it's probably a very good idea to do this yourself. I probably will do this again in another video, but it was probably a good idea to do this yourself. See if you can come up with that formula, give it in a similar way that I have done to produce this formula here. And you will find that you will end up with cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Most importantly is notice that if I do what I did in this problem where I said, imagine that these two angles are the same, so this becomes 2x, then it would become cos x plus x, which is 2x because the angles would be the same. Then you have cos x and sine x Cos x is cos squared, and sine x is sine squared. So if you have a problem, and the problem said simplify and there was a squared in here, sine squared, or there was a cos squared in there, then it would be advantageous to consider, instead of using the sine alpha plus beta, which is mostly used when you have a sine multiplied by a cos, if you have a squared, consider utilizing this tool and manipulating this. With tan, again, it might look a little bit more savage or complicated in terms of the mathematics, but actually for tan, you could do the same thing, but this time you would have to look at the opposite side, which you would call BC in this circumstance, and you would have to analyze it or divide it by AC. So this is equal to, this would be our BC. So we'd have BC up here, and we'd have divide by AC down here, and then if you were to convert BC and AC with a bit of manipulation, a bit of playing around, using your basic trigonometric identities, particularly trying to get them in terms of tan, you will end up with this formula here. And again, you could try that. I'll probably look at that. I will look at that in another video. It's an interesting one to do. But that's where this and this come from. Nothing elaborate. It's the same process I went through to get to this. You can get to cos alpha plus beta and tan alpha plus beta. It is just representing this triangle. And thence, again, if you have a problem that seems to have fractions in it, or a problem that has tan in it with two angles, then again, consider using this one in pink instead. But overall, that is what double angle formulae is about, and that is how you start tackling problems to do with them. Thank you.